Okay, so let's talk about when to use statistical tests. Okay, what kind of statistical tests should we use? Just like t-test is used whenever we have to compare the averages between two sets of data. Sometimes we need to go for the significant difference between the two means of those two data. Then we go for two-sided t-test, and two-sided t-test is actually the default t-test. Okay, and now whenever you have to find out whether mean of one group, the average of one group is significantly different, okay, that means either it is better or worse than the another, higher or lower than another, those kinds of things. If that's the case, then we go for one-sided t-test. And here you need to realize that one-sided t-test means you are pointing this thing, pointing towards some kind of direction, okay, one direction. Okay, and furthermore, you need to realize that if you have to use one-sided t-test, then we should make sure that the averages are in agreement with the statement that has been claimed. Okay, so that's what we need to do. If the statements, if the averages are in agreement with the assumption, we go for and calculate the p-value. If the averages are not in agreement, then we do not calculate the p-values. Okay, um, just like okay, so just like the engineers have better IQ than the English majors. Okay, so to prove this statement, here it's a case of better or worse, right? Engineers has better IQ than English majors. Then we look for the average IQ of engineers and average IQ of the English majors. And if average IQ of engineers is higher than the average IQ um, of the English majors, then only we go ahead and compute the p-value. If that doesn't hold, that means if the average of engineers engineering measures is less than the average of average IQ of English measures, then we do not compute the p-value. Okay, so then the operation should be aborted. Okay, so that's it. Now we all know that the next one, we all know that regression or correlation, this idea represents the relationship between two variables x and y. Okay, and in this situation what we need to do is, how to realize the problem is about regression is, you need to find out the relation between two variables. Okay, um, regression is used when we want to find if one variable affects another variable, if there is relation between two variables. If there is relation between two variables, then we go for regression. All right, and we need to realize something just like you can think of an example, uh, spending more on ads, just like in our flyers customers data set. You can see that the more number of advertisements or flyer that we distribute, the restaurant will get more members or more customers, right? So that's a kind of relation. Okay, say distributing more advertisement will get more customers in the restaurant. So that those two things, they are interrelated to each other, and in this case we need to go for regression to see how strong that relation is. Okay, and always for the p-values, okay, uh, what to interpret, or what are the statistical interpretation for the p-values. Okay, if the p-value is less than 5%, which is a very good p-value, right, in that case for two-sided t-test we say that we are confident that averages are have significant difference. Okay, if the p-value is less than 5%, and for one-sided t-test we can write we are confident that one average is better or worse, higher or lower than the another. Okay, so that's fine. And regression, we are confident that one variable affects another, or there is a relationship between two variables. And even we can say that the slope is positive or slope is negative in that way. Okay, um, we can say that. Now, if p-value is greater than 5%, then for two-sided t-test, we say that we cannot confirm that averages have significant difference. Okay, And one-sided t-test, we say that we cannot confirm that one average is better or worse, higher or lower than the another. Okay. And finally, regression, we cannot confirm that one variable affects another variable, or we cannot confirm that there is a relationship between two variables. Or simply, now if you are confused, then we can say that for p-value greater than 5%, we can simply say we cannot confirm anything. Okay, so that's one of the uh, idea that you can understand or realize. And finally, for confidence interval, okay, we always need to realize these three statements. Confidence interval is used if we want to compare the average of a variable to a fixed number. Okay, now see the difference between the t-test and the confidence interval. Okay, t-test is or are t-test are used if you want to find out the difference between uh, the averages of two groups of data, then we go for t-test. Now, if you want to compare the average of a data set to a fixed number, then we go for a confidence interval. Okay, it is just like what would be your college grade at the end of your undergraduate degree. Then you may want to approximate that, right? So that's what this confidence interval does, and that approximation is always in between something, just like let's say 3.5 to 4. Okay, so that would be your confidence interval. Okay, and if a is inside the confidence interval, then we cannot conclusively claim that the data has different averages than the given number. Okay, since a is inside the interval, then you can see that the it's within the confidence interval, so there is no difference. Okay, if a is larger than the confidence interval, we can say that the data's average is below the given number a, right? And the if a is smaller than the interval, then we say that the data's average is greater than the given number. Okay, so this is it. So three things: if you have to compare the averages between two groups of data, then we go for t-test. If you want to compare the average of a group of data with a fixed number, then we go for confidence interval. And if you want to see whether one variable affects another variable, or if there is a relationship between one variable and another variable, then you go for regression. Okay, so that's it. All right, now you can simply go through this example yourself. Okay, a company is testing a new type of engine lubricant, and their claim is that new product by lowering the frictions would increase the car gas mileage. I use the lubricants data and perform the appropriate test. Comment on the result. What test should we perform? It is saying that new product would increase the car gas mileage. So the new lubricant will increase the car gas mileage. That means the gas mileage by the new lubricant will be better than the previous one. Okay, so that's why we can go for one-sided t-test over here, and rest of the things, they are so easy to see. Okay, yeah, and yeah, you can see this one. Also, I have used hurricanes data for this problem. There's a rumor on the internet that hurricanes data with female names are more deadly than their male counterparts. Okay, what test should you perform? So see the direction over here. Okay, hurricanes with female names are more deadly than their male counterparts. So that's also one-sided t-test, right? Okay, so that's it, and yeah, so this is it. Also, there are lots of things that you can do over here. I have used maths credit salary data for this problem. It is believed that more math credits students take during their college years, the higher their salary will be. More math credit, higher their salary. Means if you study more mathematics during your college, then you'll get more high-paying jobs. That's what it says. So there's a relationship between taking more mathematics class and getting higher salary. Okay, so that's regression over here, right? And yeah, yes. And now finally, I have used maths credit salary data for this problem. Is it reasonable to claim that people who took more than 10 math credits will have average salary of 40,000 or more? So you take a group of people whose and try to see if their salary is more than 43,000, and considering that those people took more than 10 math credits. So we are comparing the average of these 10 people, these people who took more than 10 math credits, and we want to check whether their salary is uh, average salary is more or greater, equal or more than 43,000. So we are comparing with one fixed number. So that's why we go for confidence interval. Okay, this is all for now. Thank you so much. I hope you got some value out of it.